Yep.
This meeting is being recorded.
Oh, that's so good to know. Okay, so what we did this morning was the 10, what's going on here? Why is this like this? Okay, the 10-2 worksheet number 2, and most of the 10-2 worksheet number 3.
Okay.
Does that sound like what y'all, well, first I should say, is there any questions we should look at on anything before we get going? And I should say, unfortunately, it's just me tonight. Cindy's driving to Fort Lauderdale at the moment, or landing at the moment. So you're stuck with me. So be ready to jump in when I screw up.
Don't worry, we will.
Good, good, good. Yeah, I'm not really too concerned about that. You all are good about that.
Well,
So
we want to
what-
know what's going on.
Yeah, no, I mean, it's most students don't have the courage to be like, guy, you're screwing up. You just feel bad. Maybe they feel bad for me or something, but you all got it. I thought we'd start on page 689 and just like do a test. Like just throw you to the wolves. So this is the 10-2 worksheet number 2, which is your 033 homework assignment for what, Sunday? So it's this one, and then the 10-2 number 3 worksheet for 133, and I believe it's just the 10-2 stat lab.
Yes.
So a nice relaxing week because it's Thanksgiving, so you're not actually going to do any homework, which I wouldn't expect you to do any. So let's see if we can't get this all done. What I did for the morning class was I read the problem and talked through reading. I haven't done that in a bit, so I thought I'd do that again and just be like, here are the words that I see that tell me what to do. And then the other thing to keep track of is that this is the guide that I use, page 275. You can certainly rewrite this yourself, but I think the way it's laid out is nice, and it's just all set to go, and you just have to do these 6 things. And actually, if you get this down pat, 10-3 and chapter 11 adds 3 more types of hypothesis tests that have the exact same structure as this. So once you understand this structure, you're good to go. The only thing that changes is step 1 and step 3.
Is that because we're doing mean instead of proportion?
Right. So mean will have a different set of notation here, and then a different formula. Yeah. And then for chapter 11, we're comparing 2 proportions and 2 means. So we have 2 different samples, and we're saying, hey, are they different or are they the same? One of the questions that we used to do, I don't know if we still do it, was do married men talk less than married women? So, right, you compare the average number of words said by the man in the marriage and the average number of words said by the woman in the marriage, and see if there's a difference. I think that's one. Maybe I made that up. I don't know. I think it's
I'm
the
saying,
temperature.
what makes the difference if they're married or not?
Well, it's so right. That's a good question. I don't know. Someone wanted to know. That may not even be a question.
Sorry, Will and Eric, but yes.
Yes, men say less. Yeah, the other one is the average body temperature of males to females, and that one it wasn't married people. I think it'll be in the notes. It's just a group of females, a group of males. What's the average body temperature? Is there a difference?
Is this like a talk about your feelings kind of thing too?
Who talks more about their feelings, males or female? No, we don't do that.
Okay.
I'm sure there's some psychologists that do those studies. Okay, so the point is, once you know this structure, if you feel good with the structure, there's not a whole lot that changes. Chapter 11 also redoes confidence intervals with 2 samples. So again, the structure of everything we do is the same. The formula is a little different, slightly different stat crunch, but all the results and how we read the interval and all that's the same.
So
So
Cindy said everything we've done this year has come down to this. And I said, why all of the heartache for this? Why?
Okay, well, let's see if we can talk about that. Maybe. Okay, so here's our problem. We got the CDC, and it claims that the keyword prevalence rate of obesity in the US is 41.9%. Now, did you all talk about prevalence rate? Do you know what that means?
That doesn't ring a bell. Anybody else?
We talked about it, but I don't remember what we talked about.
It
Was
just
it one of
means
those
population.
keywords?
I don't know that it's one word that's used once or twice. I think it's one place in the notes. Prevalence is the percent of the population that has the characteristic. So really, it just literally means what we're about to tell you is a population value.
Okay.
Page 236 in our notes.
There you go. It shows up on page 236 in the notes. I don't know how often that word is going to show up. Those of you going into the nursing world, that's a pretty important word in the nursing world, I believe. You know, maybe we can talk about the prevalency rate of AIDS or the prevalency rate of I don't know, any kind of disease or something. It's just the percent of the population that has it, which means this 41.9% is going to be our P naught. It's the presumed value of the population. So the claim here is that 41.9% of all Americans fit the definition of obesity, whatever that is. Okay, so then we got a researcher for the Jackson County Health Department. Notice this immediately tells us we're talking about a subset of the population. US is all, we're now looking at just Jackson County. And then this word is also a keyword, believes. That's a claim. That's another word for claim. So a researcher for the Jackson County Health Department believes that obesity rates in Jackson County are significantly lower than the national level. All right, that's another really important thing here, the word lower.
Yeah.
Right, now we know the alternative hypothesis. And then this isn't like as important, but it connects back to the prevalence rate. This is just saying it's lower than 41.9%. That's the national level. So we've got a statement about the population. We have to trust that the CDC knows this somehow. They would have done studies to determine this as the prevalence rate. Then we've got a local researcher here in Jackson County. They think that Jackson County has significantly lower rates. And so they go out and they gather here comes a bunch of stuff, a random sample of 200 adults, right? That's N equals 200. I don't know how large Jackson County is as a population. I want to say it's around 30,000, maybe. I don't know if anyone knows. I don't know. So they select 200 randomly, that's important, and they find that 37% are classified as obese. All right, that's our P hat. So one thing to notice that you probably have already noticed is when you're working with a hypothesis test, you always get two sets of numbers: population values, parameters, which for a hypothesis test we call P naught. Right. And then statistics, values from the sample. So the sample size, the P hat, the sample mean, the sample standard deviation. You're always going to get two sets of numbers. You've got to keep track of what are the population stuff, what are the sample stuff. And then we test the researcher's claim at a 5% level of significance, showing all steps work and graph. So this word level of significance is the exact same thing as alpha.
Alpha. Mm-hmm.
Yeah, and we always give that to you. Now remember, alpha is the probability of making a type 1 error. That means we are saying we are not comfortable with a higher chance of rejecting the null hypothesis, higher than 0.05. So now let's connect this back to the chapter 8. Remember the 3 conclusions? If we get a result that was highly unusual, what are the 3 things? Bad sample, or bias in the sample of some sort. Fluke, it
Fluke.
happened by chance,
Right.
And the parameters are
The
bad.
bad parameter.
or the parameter is different, right? So what we're doing here is we're saying we are not going to classify our results as a fluke if the p-value is less than this alpha. Then we're going to say the parameter is different. So we're doing the bad parameter thing. We're testing, is this true? Really, we're testing a claim that says this parameter isn't true anymore. Something's different. It's lower in Jackson County. If our value is above 0.05, our p-value, then it happened by chance. It was a fluke, which is a little weird because that's the opposite thought from what we did before. It was a fluke if it was a really small chance of happening. But if you remember chapter 8, we were talking about parameters. We knew the parameter and we were messing with the result, the sample result. Okay, so question. Can you do the hypothesis test from start to finish? Okay, let's do it.
I think so.
Here's how I like to see it laid out. Doesn't have to be exactly like this. I kind of like it. I will always do this when I write it. I'll write S1 for step 1. And then you're going to do HO, and you're going to write out whatever that is.
Right.
Or 1. And then step 2, you're going to tell me what alpha is. And then step 3, I think Cindy said you just wrote down the equation and then its result. And that's really all you need to do. You don't need to do all the substitution. So let me give you 5 minutes and you all just go nuts. See if you can do it. If you get stuck, call on me to help me unstuck you. Yeah, and we'll see where we're at. Like in 5 minutes, see if you can't get steps 1 through 3 done. Set a timer for 5 minutes. So that was 5 minutes. Should we check in on step 1 at least? First, we should have practiced what I had talked about before. Are we working with a proportion or a mean, and how do we know?
There's a p hat, so we know that's a proportion.
That's it. The percentage and the p hat and the percentage and the prevalence rate, the word rate will do it. The p hat, all of that tells us this is a proportion test. Also, it's 10-2, and we're only going to be doing proportions in 10-2, but that doesn't help for the midterm or the final. Okay, so doing step 1 is really just a matter of figuring out which one of these 3 things is it. So this part, where is it? This one part is always going to be the same. Why would this not let me draw? That is, you're always going to have a p equals a p, and you got to figure out one of these 3, and then they're going to be compared to the same number. So we know p equals something, and then p something, and then that same something. I told you the p naught already, right? 0.419. So we know that's what goes here, and these numbers must always be the same. Otherwise, we're not making a claim. So the question is, what is going to go here? Less than, not equal to, or greater than? And how do we know? Less than, nailed it, Will. And it's stated in the belief statement or the claim statement. That's always where you're going to find where that inequality goes. So let me highlight that statement. It came right here. Jackson County Health Department believes, and here comes, that obesity rates in Jackson County are significantly lower than the national level. That's the statement of, or the claim. That's what we're going to try to support with evidence from our sample. And so then within that, we're finding the word lower that tells us less than. How'd you all do? Good. My opinion is that if you can get this right, the rest falls out. If you can't get this right, the rest ends up being wrong, which is mostly true. I mean, it is true. Anyone know the alpha?
0.05.
Good. Every
But
semester
you
I
wrote
teach
it up there, but
yeah, right. Yes. But it is that easy. You just have to find it. It's either going to be written as percent level of significance or alpha equals significance. So there's only 2 ways you're going to encounter step 2, and everyone should get that right, because it's always just write it down from what we told you. How'd you do for step 3? At this point, you should just be copying down this formula. That's the one thing. So that's the test statistic, the P naught is P hat minus P naught divided by the standard error of the P naughts, which is this part. Now you don't do anything with that. You just write it down.
Right.
And then it says technology. StatCrunch, select stat, proportion stats, one sample with summary. You already did that in chapter 9. I'll do it again, even though I had it open. Stat, proportion stats, one sample with summary. Now, in chapter 9, we kept clicking confidence interval because that's what we're doing. Now we're doing hypothesis test. But what do we write for number of successes?
that's X.
That's X. Good. Do we know X?
No.
No.
Can we know it?
Yes.
Yes.
Yeah, you all know this. Yeah, good. Right. So we know X is P hat times N. P hat was given to us. N was given to us. So we just do this, and that's our answer. I believe this is 74.
That's what I got.
It is. Yeah.
Good. What's number of observations?
The sample
It's
size.
N, sample size. Good. If you're not remembering that, We told you to write it down for chapter 9 that X equals this and N equals this. I don't think it would hurt to rewrite it here as well. Like maybe right next to this mess. I got to reopen this. I don't know why this opens so wonky. Just because you know how it is when you're taking an exam, you get nervous and you know, it could be you just don't remember. And so if it's there on your reference sheet, hopefully life is better and you won't forget it. Okay, so the only other thing you have to be careful of what you put in, well, there's two other things, right? We need to get the correct P naught. There it does it. And then we need the correct inequality symbol. I'm going to suggest that it might be helpful to click the p-value plot. You don't have to, but it'll generate the graph for step 4. Let me see if I can get back to where that was. 275. Yeah, it will create this graph for you if you select that. So when you click compute, here's your z-stat or your z-naught. Here's your p-value that goes with that. And then if you did click the p-value graph and you click over, there's what it should look like. Which is, you know, it's a left tail test. We knew that already. So you could have just copied this. Doesn't particularly matter, whichever way you want to do it. Okay, so I'll leave you to do step 4, 5, and 6. Are you another 5 minutes? Does that seem
Just
like?
Eric, we may
Please.
have gone over this and I don't recall, but is there a standard number of decimals we should use?
Great question. So usually we do for the test statistic 3, because it's like
3,
the critical
okay.
z-value kind of. And then for the p-value, you need enough to correctly compare it to the alpha. So alpha has 2, so maybe you should at least have 2. I tend to like to have 1 more, which would be 3, but that doesn't really make a difference for this number.
Okay.
So it's just as so that you can correctly compare the p-value to the alpha value. All right, I'll leave you alone for another 5 minutes. Set a timer for 5 minutes. Okay, excuse me, that was 5 minutes. So was everyone comfortable with just like drawing this graph?
Yes.
Oh.
It doesn't look very pretty, but yes.
Don't worry about I mean, look at mine. It's not great either. So the idea is just that we're noting, hey, this is the critical Z value. Oh, look at you, Will. Oh, that's, yes, look at that. Of course, that won't work on the final exam if you're doing paper and pencil, but look at that, copy and.
Now, Will, that's a lot of words.
Yeah. Why won't it copy? Why can't I paste in here? Oh, it's because I have to do, is this the one? No. Is this the one? There we go. So this, where's the paste? It won't let me. Okay, well, I need a Word document apparently. Yes. Do we feel good about that? So there's that. And then step 5, I encourage you to write this piece right here, because that's the thing that we're testing. We're saying if this happens, then this happens. If the p-value is less than alpha, then we reject HO. So how I like to see it, you don't have to write it this way, but I like to see writing out the statement we're testing, then writing down our p-value and checking, is that actually less than 0.05? I've seen students do it other ways. They write out the correct statement, and sometimes that messes them up, sometimes it doesn't. But what is your all's response when you see this? What do you think? Do we reject or do we not reject?
Do
Reject.
not reject.
Okay, did I get 2 different answers or 1 answer? Do not reject HO. So if you're someone that struggles with these inequalities, which don't feel bad if you do, here's my method to guarantee correct results. Is that right? I don't know. That sounds like a snake skin oil or whatever. What I do is I look at the decimal place and we can ignore the zeros because they're the exact same number. And then we come to the first non-zero number. And so we're going to compare this 8 to the second number over here. So is 8 smaller than 5? The answer is no. So this is not true. So we do not reject HO. What we're saying is there's too high of a chance that we make a type 1 error. We're only comfortable with a below 5% chance of making a type 1 error. There's, I don't know if this is the exact correct thought, but there's potentially an 8% chance of making a type 1 error. Meaning if we were to reject HO, we may not actually be making the correct decision. Okay, so from that, we just have to write up the statement. And I think you all know the part, right? You've got the first part of script. There is either enough or not enough, or there is sufficient or not sufficient. I like the word not because it costs less to write it. It's easier to spell too, or I'm sorry, enough as opposed to sufficient. That always is challenging to, you know, those I's and E's and C's and afters things. I don't know. So there is not enough evidence, meaning our sample results are not strong enough to support the claim that, and then here we just copy and paste the claim from here. Notice there's even the word that in this. And then everything after that is what we'd write down. But I just screwed up because I can't. Can I select it back? Oh, I can. Look at that. That the obesity rate of Jackson County is, I'm just going to take out the word significantly and say less than the national average. We don't even have to put in the number for the national average, which is 41.9%. We can, but we don't need to. And that's it. How'd y'all do?
Good.
By the way, the only difference in step 6, if we rejected HO, is we would take out this word and say, hey, there was enough evidence. When you reject the null hypothesis says there is no change. The assumed value is the assumed value. And then we just gathered evidence to try to show that it's different. And note, we weren't claiming anything about the population in this particular study. We were just claiming that our local county is different than a national. And based on this, we don't have enough evidence, even though the percent itself was lower, right? 37% is lower than 41%. If it wasn't, if our p hat was like 50%, the problem would be done because we have no evidence. This is just saying our evidence happened by chance. So there's nothing special about Jackson County. Okay. Do you want to just do one more of these start to finish and just like feel like you've got it? Let's do that then. So I won't say anything. This is what a question looks like on the final exam. Do it. So I'll give you 5 minutes. We'll do steps 1 through 3. If you can't get step 1 right, then you're kind of sunk. So I jumped to page 692, which is the last page of the 133 worksheet. And this is the same thing that we just did. A nice big hypothesis test. So 5 minutes and enjoy. Set a timer for 5 minutes. So that was 5 minutes. And I just want to check that we all agree on step one, and then I'll leave you alone some more. I'm assuming we established that this is a proportion because of the 91% and the 96% and the word rate. Those are the three things I would look at for proportion. What number did you all use?
0.91.
Good. How did we know that that is the assumed P naught value?
Because it's the population.
How do we know it's the population? What were your clues? I agree. It's definitely the population value, but how did you know that? Why did you make that decision?
Because at the University of Massachusetts,
Great university, I guess. Dartmouth, is that well known? These same researchers, so this 96% is also University of Massachusetts, Dartmouth, right?
yeah, but in the beginning of that sentence says random sample.
Key point, right? This 96 is attached to a random sample. So by process of elimination, the 91 has to be the population. Yes, that's an excellent way to do it. We're only going to give you two numbers. One is the proportion for the sample, so P hat. One is the assumed proportion of all. Good. The other clue is this phrase right here, of Fortune 500 companies. How many of them did they survey? It doesn't say a number anywhere, and it's an implied all. Whereas down here, we have a specific number of Fortune 500 companies, 150 of them. Cool. Okay. Did we get the symbol on this? Less than, greater than, or not equal to?
Greater than.
How'd you know greater than? What word?
Higher this year.
Yeah.
Word higher.
The word higher. Excellent. Okay, I'll leave you alone. I'll do another 5 minutes and then check in to see where you all are at. Set a timer for 5 minutes. Okay, sorry about that. Did we all have enough time? So I'm just going to quickly write in a few of these. I know I haven't been writing in answers for a while, so tonight is an exception, right? Is everyone comfortable with the 0.01 and where that came from?
Yes.
Yeah.
Right here, this time it said 1% level of significance. Good. Okay, so then we have to do the same thing we did in the last one. We've got to know that X is equal to P hat times N. And our P hat is the 0.96 and our N is the 150.
Right.
And that's what we need. In terms of substitution, this is probably really the only thing I need to see you write down is what did you type in for X? What did you type in for N into StatCrunch?
Mhm.
Because that's really all that matters in terms of StatCrunch output. So we got that, and then we need to 0.91 for our hypothesis test, and this is a greater than symbol. It's a right tail test. Like I said, I like having the p-value shown. So the p-value plot selected, you don't need it. And here's your results. You got 2.140 for Z naught, correct?
Mhm. Yep.
2.140 when rounded to 3 decimal places. And then there's your p-value. Here's our plot. So for step 4, we're just drawing that as a way to confirm we see our graph. Shroop-de-doop. Here's our Z naught value, 2.14. And here's the right tail area associated with that Z naught value of 0.016. I guess that's enough. So we have the hypothesis tests, we've got the level of significance, we now have the p-value and the test statistic. So now we can make our claim, or we can evaluate our results by determining, is the p-value actually less than the alpha? And you all said no,
Oh.
right? Good. So we're comparing the third number because the second number is the same. And the question is 6 less than 0. It is not. Boy, 2 in a row that failed. They're not all going to fail. But I mean, treat each one separately, right? So this is not true. So we do not reject HO. Good. Step 6, I've had students in the past say, do we really have to write this out? Yeah, it's like actually the most important step. Because this is where we talk about the results of our work. And here we're saying there, again, is not enough evidence to support the claim that, and what was our claim? That, let's see, right here, the same researchers believe the Twitter usage rate is higher this year. Now, this year is like probably past from when the problem was written. So we could just say Twitter usage rate is higher than 2019's rate, which is what I did. So support the claim that Twitter usage, let's say it this way, that the Twitter usage rate, and technically we should say of Fortune 500 companies. You don't have to. I'm just to make it clear. If we read the problem and if we didn't read the context, just saying Twitter usage rate is higher than 2019 doesn't say for what group. And our population here was Fortune 500 companies. Okay, so claim the Twitter usage rate of Fortune 500 companies is higher than 2019 rate.
If you
I'm
did,
not going to be super picky about this. Go ahead.
because I was gonna say if you did, because I did write higher than this year, but I wondered if I should. So would that be wrong? If okay.
No, that's fine. It's totally
Okay.
fine. It's unfortunate because clearly this worksheet was written in 2020, right? And that this year is actually referring to 2020, but yeah, right. And then Twitter, it'll be like, Twitter doesn't exist anymore. So, so it's 0%.
So Eric, I don't know about anybody else, but I struggle with the sentence to pick up after proportion. Like to pick up, like you said, that the Twitter usage rate of Fortune 500 companies is higher. How do you clue into how to figure that one out?
So let me make sure I'm understanding the question. How do you figure out this part?
Yes.
Gotcha. It always comes after the claim or belief statement.
Okay.
And many times it's researchers claim that, and you can just copy and paste everything after that word. So it's either believes or claims. Those are the two most common. Believe.
Okay.
And it's the same sentence where you got the alternative hypothesis from. So if you can figure out what the alternative hypothesis is, you know what the statement should be down below, or at least where the sentence is.
Okay. That's helpful. Thank you.
But yeah, that's a good question. Okay, so if you got this one as well, you can do hypothesis tests. You're good. Means have more numbers in them because you're going to get a population mean and a population standard deviation, and you're going to get a sample mean and a sample standard deviation. And then you're also going to get a sample size. So that's 5 numbers all jumbled together in the sentence. Whereas this one only really has what, 3, really 4, but really it's just the 2 percentages, p hat and p naught, and then the sample size. Sometimes we give you X. So let's do one that sometimes is more challenging. So I'm going to leave this one for you to work on. If we have time, we'll come back to it. This is another hypothesis test. We just give you step 1 and then ask you to verify the requirements. And then step 3 or question C is steps 3 through 6. So let's go back to a stranger one, or not a stranger one. Let's go back to one where we give you everything and then ask you questions about it. So here's the prompt with some of the information. And then here's an output with some of the information and some of it conspicuously missing. Standard error, sample proportion, and then a bunch of different questions. So kind of what this gets at is more, do you know the vocabulary of all the stuff? Whereas like sometimes you can, like when you do these hypothesis tests, you can just get in the thing of first I do step 1, then step 2, then step 3, then step 4, then step 5. And you can, in some ways you can do these steps without kind of mindlessly, right? You can almost just not really know what's going on, but know how to put it together. And then this gets in the in-between bits of like, do you know all the little working pieces? So let me give you 5 minutes to try this. There's some old school like section 1.1 questions in A and all that. So yeah, just try it out. And if you get stuck, let me know. Set a timer for 5 minutes. Okay, let's check where we're at. Everyone clear why this is observational, not experimental? Or not designed experiment?
So it would be, I wasn't sure how to word it, but it would be unethical to um, I don't know, select random students to see if they are receiving free or reduced lunch. I wasn't sure how to word
So
it.
you can, it's okay to randomly select students and determine what they're receiving. I think that would be okay. If we were to design this, we would have to be randomly assigning students to receive free or reduced lunch.
Yes, okay.
And I don't know that that's unethical because we essentially did that in COVID, right? We
Yeah.
assigned free or reduced lunch to every student. We
Everybody.
just said, everyone's suffering. Let's just give lunch for free to everyone. I think really, if you think about what's tied to free and reduced lunch, that's your income. And so you're looking at family incomes that are, I don't know what the criteria is. It's like at or below the poverty line. And so trying to assign family incomes to students, that's like, it's just not possible. And it's probably not ethical either if you're like, you're only going to make this much. So yes, that's the right idea. It's the random assigning of this thing that we're looking for, which we can't do it. It's not possible. Good. For B, did you all just copy and paste this over here?
Yes.
Good. So the words are that the population proportion is 51%, 51.1%, and the alternative hypothesis is that it's not equal to 51.1%, the percent of students who are on free and reduced lunch. Okay, good. I'm guessing you got C. Has anyone got stuck on any of these? D, E, F? Does everyone know the population size is 32,098? So there's 32,098 students in the Grand Rapids school system. This was back in, does this give us a date? 2020 to 2021, there's that many students in Grand Rapids. Now, E and F are key. Did you all figure those out? This is figuring out what's the sample size, and this is figuring out what's X. So how many were sampled? It's here. Did you all find it?
Is the sample, is the children sampled would be 172?
Good. It's the count, and it will, StatCrunch always says that. Sample size is count, and the other one is
105.
good. I said that wrong. The sample size is always total, and the count is always X. Like, I don't get why they can't say successes, because that's what they had elsewhere, right? Like, why can't they be consistent here? Why can't it be successes and observations? But they give it count. How many of them were successes? Total is how many did we have in the sample? Okay. Did everyone get P hat?
Didn't get that far.
Okay. I'm going to write this and I'm going to set the timer for 5 more minutes and let you roll. I'll leave this up so you all can see this part. Set a timer for 5 minutes. Okay. How'd y'all do with p hat?
0.610.
Okay.
Yeah.
Good. Did you find the standard error of p hat, although we're told to use p naught for the standard error? Did you find that formula? Turns out it's in step 3. It's the denominator. So if we want the standard error of p naught, which was maybe what we should have asked for, it's just the square root of p naught times q naught divided by n. We will always know p naught from step 1,
Mm.
and then 1 minus that p naught gives you q naught, and we'll know n from the sample size, and away we go. So the standard error of p naught is equal to the square root of p naught times q naught divided by n. And this is that one where it might be nice to use Desmos. So what, 0.511 times 0.489 divided by 172? Or do I have the wrong numbers in my head? Nope, that seems right. So I don't know if I showed you all this in Desmos. Like if you get the square root in there first, so hit the square root button, then hit the divide button, and you'll have the fraction within the radical. That's another name for a square root. And then you can just type in 0.511 times 0.489, put the down arrow, type in your 172, and there's your answer. 0.038.
I just put it in StatCrunch.
Oh, as in, oh, I see. You put, okay, I got you. And you got the standard error from right here.
Uh-huh.
That's totally fine too. Why not? Right? We got the tools. You knew the 105, you knew the 172. We tried to hide it from you to get you to like use the formula, and you're like, nope,
Sorry.
can't trick me. Sorry. Love it. Yeah, I respect that. Yep, why not? Just in case everyone's noting, there it is. There's also the sample proportion. So your p hat you could have gotten the same way, although this may be faster. Good. Okay. Ugh. Are you getting sick of these verify the requirement questions? C1, random. Given. C2, independent. This time we gave you the numbers. 172 less than or equal to 0.05 times 32,098. Check. It's like 1,600, right? So that's good. Now C3 is new. It's different. Did you note it? Did you note how it's different for a hypothesis test than for a confidence interval? And this might get you on the chapter 10 project, because in chapter 9, it's n times p hat times q hat. In chapter 10, it's n times p naught times q naught. It's a subtle difference. We use the assumed parameter value to check for normality, not the sample value. Did you all catch that, or did that catch you? I don't know.
I got it.
Good, good. It's just a tiny little difference. It's the most common thing missed on the chapter 10 project. Okay, so we're happy with that.
Mhm.
Am I losing anyone? Are we all doing okay? Step 4, we're just supposed to draw the results that were printed there. Kind of, I don't know, sometimes it feels like, why are we asking you to do this? But it is good practice. This was two-tailed, so we know there's area here and area here, but the p-value is shared between those two areas. So 0.0091 is the sum of these two spots. And so if you look at the reference sheet, it shows it like with arrows here. And then we only ever give you, or StatCrunch only ever gives you one z-stat, 2.61. But we actually know both of them, right? Because z-scores are symmetric. Whoops, that was supposed to be a 1, sorry. And that's supposed to be a negative. And then step 5 is, okay, is this p-value that we found less than the alpha value, which this time, instead of saying level of significance, we actually just said alpha equals. So you're taking the two areas and comparing it to the one alpha. This time it's true, so we reject HO. If we were to write out the thing, we would say there is enough evidence to support the claim that the number of students on free and reduced lunch has increased from the 2020-2021 school year, or increased from, I don't know which is which. It has, oh, we're just saying, we can't say increase, you'd say it's changed. Although we've shown an increase. Our sample suggests it's an increase. Okay, then the trickiest question of them all. If it was actually 51%, we should have failed to reject HO, right? That's what this means. The null hypothesis is true, so we shouldn't reject it. Which type of error did we make? And there's that handy little table on page 230 that I think you should put in your reference sheet if you feel like you're going to struggle with this. If HO is true and we reject it, we make a type 1 error. If the null hypothesis is false and we fail to reject it, we make a type 2 error. So one way to remember that is if our conclusion in step 5 is reject, the only type of error we can make is a type 1 error. Either we're correct or we made a type 1 error. If the conclusion in step 5 is fail to reject or do not reject HO, the only type of error we can make is a type 2 error. So in this case, it's a type 1 because we rejected. We're being told this, what this statement means is that HO is actually true. I don't know how we know that. We're just saying, pretend it is true. What type of error would you have made? It'd be the type 1. Okay, how did that feel? Was that like worse or better or eh? In my experience of teaching this class, and I think it's because I tend to emphasize being able to do this, the test from start to finish so much, students do worse on this part of the exam than on the blank page part like this.
I would agree with that.
This is all the
I'm-
little tiny minutia,
I mean,
right?
there's
Yeah,
little
because-
pieces and parts I'm missing, but getting it mostly overall, but
I think with the blank thing is because we could do it in each step on our own.
yeah.
There's a nice process where this is like, grab this little piece, grab that little piece, figure it all out. Let's just talk through number 2 real quick. We can use StatCrunch actually to answer number 2 if we wanted to, because we can get the p-values associated with each of these test statistics just using the normal calculator like we did in chapter 7, right? There's nothing special about Z naught. It's just a Z value that we can use a calculator to find the area, the normal calculator. Since this is a negative 1.3, we're just saying, well, how much area is there less than 1.3? And that answer is 0.097, right? And then for negative 2.4, we're just saying how much area is less than negative 2.4, and it's 0.008. And how much area is above 7.6? Doesn't even matter that these are 1.6. That's 0.055. And then above 2.7. That's 0.003. So the thing to note, though, is when we talk about a Z naught as a test statistic, the area is the p-value, which is our value that we compare to our alpha. So we use Z naughts differently than we used Z critical values back in chapter 9.
So where did
So
you go for this, Eric?
I just went to the normal calculator, just like we did in chapter 7. And I just calculated the area to the left or right of these Z values using the normal calculator. So if they're negative, I want the left tail area. If they're positive, I want the right tail area. I know that because these are all two-tailed tests, so I know where the particular areas are that I'm interested in. So the key thing here, though, is you don't have to do this. We're gonna generalize this. What do you notice? Which numbers have the smallest p-value? So in other words, which of the,
right?
yeah, now look at the number 2.7, and the next smallest is the negative 2.4. So it turns out the negative number doesn't matter. What matters is how far away from 0 is the test statistic. The further from 0, the smaller the p-value, which is why we often talk about the absolute value. We just say ignore the negative part. It really doesn't affect the size of the p-value. What matters is how far from 0 are they. 2.7 is the furthest from 0. It's
Can you say
further
that
away.
again, Eric?
Yeah,
The farthest?
the furthest from 0 has the smallest p-value.
Thank you.
Yep. And then the largest p-value is the closest to 0, which, if you note, happens to be study A. Even though it's a negative number, the distance between 1.3 and 0, sorry, negative 1.3 and 0 is smaller than the distance between 0 and 1.6. Like, this number is closer to 0. It's on the left side. It's a negative number, but its distance from 0 is the least. So it has the most area to the right of it. Or in other words, the largest p-value. So another way, you could write a little thing. If we increase the Z stat, the absolute value of it, this just means the positive version of it. That means we've decreased the p-value. So you don't need this calculator. You just need this knowledge. I used the calculator to help us see the numbers to build the knowledge. I hope it was helpful.
It is, because I feel like I might get hung up on the negative numbers.
Good. So throw away the negatives.
So
When it
just
comes to
don't even look at
p-values, the
those.
negatives don't
Okay.
matter. Look at them all as positive, put them in order from smallest to largest. The largest number has the smallest p-value. The smallest number has the largest p-value. Okay, one other bit of language. I think we've completed all of the 033 worksheet, haven't we? We have. Good. So one more bit of language. This is now 690. If I'm going too fast, slow me down.
Slow down, please.
Done. I'll go get a cup of water while you all write. Okay. So this is page 690. We're back to the 133 worksheet. Does anyone know what statistically significant means? It turns out it's a very specific thing.
Alpha.
Close. That's really close. It's a relationship with alpha. In fact, it's step 5. That's all it is. Statistically significant results are results for which the p-value is less than alpha, which we know means we reject HO. Which also we know HO, the words for that are null hypothesis. So all of these words mean essentially, well, not all of them, but this statement and this statement and this statement mean the same thing. Statistically significant means the p-value is less than alpha, means we reject HO. Do they actually mean each other? Maybe I'm being a little like they're all connected. So if we rejected HO, then the results are statistically significant. If the p-value is less than alpha, then we reject HO, which means the results are statistically significant. So they're all connected. I don't know if they're all mean the exact same thing. And then I added in that HO means null hypothesis, because here we're like, hey, the null hypothesis is rejected, meaning HO is rejected at alpha equals 0.01. Well, how do we determine if we reject something? Is the p-value less than alpha? So maybe the big umbrella word for hypothesis testing is this: is the p-value less than alpha? That's our thing, right? We're basing a lot of our thinking on that relationship. So what's your answer to A? Is it true? If the p-value is 0.03, then HO is rejected at alpha equals 0.01 level. True or false?
I'm gonna go with true.
Okay, why? Oh, I'm so mean.
Because on another problem we had, it was kind of similar, where the p-value was less than the alpha, and we rejected it.
Okay, so let's write it out so we can see if it's true. Is this number actually less than this other number? So if I put it in the p-value less than alpha form, this is what the statement we're evaluating. Is that true?
No.
It's not. So that's not true, which means
Mhm.
if we were just doing this, we would do not reject HO. Which then means this statement here is false, right? Because
Right.
it's saying that we should reject HO, but that 0.03 is not actually less than the alpha. If our alpha had been 0.05, this would have been correct. Because 0.03 is less than 0.05. Okay, B is the same exact question, just different numbers and different words. Right? Statistically significant means reject HO, which means that the p-value is less than alpha. So is that true? Is this p-value 0.03 less than this alpha of 0.05?
Yes, it is.
Yes, it's true.
Good. So it's a true statement. If it's helpful, like if you're struggling to keep track of it, I encourage you just write it and substitute it. Here's where the p-value should be, put it in. We want it to be less than, here's the alpha value. and then compare those second numbers and say, is 3 smaller than 5? It is. Good. So this was a true statement. Here we're saying, is 3 less than 1? It is not. So it's a false statement. So do not reject HO. Now C is a different question, but it's kind of a riff on this p-value less than alpha thing.
Question.
Please,
So,
go ahead.
I don't know about anybody else. I'm struggling, like you're adding the do not reject and the reject and is the question asking us that?
No.
Okay, so to decipher between the two, I'm getting them confused. How do we, because when we were going over do not reject and reject, it was in the hypothesis testing with the boxes and everything, and that made sense. But this, I'm not sure how to understand the difference of those.
Great question. This is just step 5. That's all this is. So when you did step 5, down here,
Oh, okay.
that the criteria, the only criteria we're concerned with is whether or not the p-value is less than alpha.
And she did give us yes or no and what that means. I just missed it. Okay, cool.
I get it's tricky because we're like pulling this one little piece out of this big process and saying, hey, check this out. Make sure you get what this is. Which is kind of what 10.1 was. It's like, here's how you do step 1. Here's how you do step 5 and step 6. And then here's an error. Okay, so then this next one is a rift on these two problems. Note, it's not asking for statistical significance, actually. Ooh, there you go. Let's look at what's 237. Okay, yeah, here's some more. This is where statistical significance is played with some more on page 237 of your notes. And this is where it says specifically what this rejection means. We're saying it's highly unlikely that the null hypothesis is true by chance. Like it's highly unlikely that it accidentally happened. So we're going to reject it. Okay, so this one just says, hey, is this p-value of 0.03 less statistically significant than a p-value of 0.04? So we're comparing p-values. So let's start with what if our alpha is 0.01? Would we reject HO in both with either of those p-values? Gotcha. I see some head shaking. If you're wondering, how do I know to reject HO or not? This is how. Is the p-value less than alpha is the question. So the first one is 0.03 less than 0.01.
Yeah. No.
No, right. It's 3 is bigger than 1, so don't reject HO. Is 0.04 less than 0.01?
No.
No. So neither of these are statistically significant results. Let's change the alpha. What if I change it to 0.05? What happens then?
Then they both would be.
They both are reject. Okay, so which one has more evidence? Which one is the better, the stronger rejection? Which is to say, which of those two p-values is further away from 0.05?
0.03.
Good. So the take-home message here is the smaller the p-value, the more statistically significant.
Mhm.
If their results are statistically significant, right? In my first example, neither of them were statistically significant. In the second one, they both are, but the 0.3 is more. So this answer is false. This statement, it says a p-value of 0.03 is less statistically significant than a p-value of 0.04. And the answer is no, because 0.03 is smaller than 0.04. That's why. So to generalize the statement here, this is the take-home message. The more important thing is not that you can get this answer right, but that you understand the smaller the p-value, the more significant the result. Now, that's only true if the results themselves are statistically significant. How you all doing? Is that, this is kind of tricky stuff.
Yeah, for some reason, these are throwing me a little bit, but I'm not really sure why.
There's no context to them, right? So it's like, what are we
Because
using?
they don't, it doesn't really throw me when doing step 5.
Right.
So why does it here?
Yeah, right. Because because it's not like the next thing. It's just it isolated, right? So I'll
Oh.
reiterate because go ahead.
No, I was just gonna say, I think why it's throwing, I don't know about you, Nicole, but it's throwing me off is this, you're asking us one step further. Could we decipher whether the number we're getting is less than alpha? Yes or no? We can. But this is asking us one step further.
Yeah,
What does that mean?
True, false, do we reject it? Do we reject it? We do not. I think that's what's throwing me off for sure. I just have to look at it.
Good, good. That's good that you can verbalize that because that's really, you're right. That's exactly what this is doing. It's going beyond just can you tell if the two numbers are smaller and its result. It's then, okay, now I'm giving you a bunch of different numbers. Which direction does it go? But it's all based off of this one thing. If this is
Mhm.
true, then this is true. And then kind of messing with that. Okay. So if we read what's left on this worksheet, this says, what are the hypotheses? Can you write out step 1? The B says, the B one is just like, hey, do you know the relationship between the test statistic and the p-value, which we wrote? I think you all can do that. Question 3 is just a reiteration of what we just did, asked a slightly different way. Which p-values are more statistically significant or less statistically significant? The smaller the p-value, the more significant. And then question 4 is just one more hypothesis test. So maybe I should give you, what you want to take 5 minutes on question 2 and 3 and just see where you get. And then if we run out of time, we don't, like, I feel like you all are pretty good at number 4, like you can do it. So let's do 5 minutes on this and see where we end up. Set a timer for 5 minutes. Okay, that was. Five minutes. Tricky question. Anyone know the definition of fair from chapter 5?
Could not remember it.
No worries. Equally likely outcomes. What would the percent be if there's two outcomes and they need to be equally likely? What
50%?
Say it again.
50%?
You got it. So HO is that the probability is equal to 0.5. What would not be fair?
Not equal to.
Not equal to. Nailed it. We don't particularly care which way, right? It could be fair if it's less than, or it could be fair if it's greater than. Doesn't matter. And what we're picking here, by the way, is heads. We could, the same thing would be for tails, right? It doesn't matter.
So,
Awesome.
so I put that as P equals heads because I had no idea what to put there.
Good. Not so you just have to remember this has got to be a number. These
I
are
figured that, but I just, my mind would not go to what that number
Love it.
would be.
I mean, this was so old. When's the last time we talked about fairness?
Okay.
Yeah. And then that could get to equity versus equality. Those are words out there these days. Okay. Now, the answer to B, we wrote a sentence for it. Did we not? Did we write it? Where did I put it? Oh, it's right here. The larger the absolute value of the test statistic, the smaller the p-value, right? So this says the students collected the data, ran a test. Student A has a z-naught of 1.8. Student B has a z-naught of negative 2.1. But remember, we don't care which one's positive, which one's negative. So which one has the smaller p-value?
Student B.
Good. Student B, because their number is further from 0.
Yep.
Good. Because 2.1 is larger than 1.8. That's another way we could say it. Okay, good. If the p-value is less than the level of significance, we blank the null hypothesis. Let me write this in another statement. If this is less than this, what do we do to HO?
Reject it.
Reject it.
Nailed it. Okay, so this is the English version. This is the math version. Right? Symbols, p-value less than alpha. If the p-value is less than, and these words are the same as that. Level of significance, same thing as alpha. Null hypothesis, same thing as HO. How fun. The smaller the p-value, the stronger the evidence against the blank hypothesis becomes.
Do not reject.
Good. Well, the smaller, the more likely to reject. The question is,
Okay.
which hypothesis is it? The null or the alternative? Go ahead.
I was just gonna say, I put null.
Good. Have you noticed that we don't ever talk about the alternative hypothesis?
Ever.
Ever.
Mhm.
Even when we get statistically significant results, we don't say the alternative hypothesis is true. We just say, hey, we got evidence to reject the null hypothesis. It's kind of the weird stats speak. Although in my grad classes, we were a little less like lawyerish. My professor would say, okay, we accept the alternative hypothesis. We accept it as true. Whereas this is more lawyerly. It's kind of like, well, we didn't really say it's true. We just said we got evidence against this thing, which is like a more careful language.
Excuse me.
Okay.
Okay,
so
Eric, a bunch of math geeks in a room.
that's where I was in Toronto. Apparently there
Can't
were
do it.
700 math professors all in one room. And we talked about math. And I went to one presentation and this guy's like, so it's Saturday afternoon and we're going to talk about math. So I'm assuming this is a sympathetic audience when I talk about mathematics, because who else would talk about math on a Saturday afternoon but a bunch of mathematicians?
Full
was fun.
respect, but not what I want to do on a Saturday.
Yeah, it was a good presentation. The guy is kind of a big name in the math world. It was fun, but
Was it at least entertaining?
I'll be honest, his presentation was a little slow for me.
Was it a little slow, a little dry?
Slow, a little dry. I expected different, but it was good. It was actually really cool. His thing is about equity. How do we and about social justice. How do we use math to promote justice in our society? And his thing was like, you look at math is the answer. We got to teach people mathematics, teach people to think about mathematics, and we will eliminate some of the problems in society. Because if we can teach people to think, a lot of the hate and anger might actually go away. I'm like, oh, I like that, Stan. Anywho, here is the last question. We don't have time to do it, but I think you all got it. Let's just check the researchers' hypotheses. We know this is a proportion because here's a percent, there's a percent, everywhere is a percent. Now, remember to be careful that level of significance is sometimes given as a percent. You're going to see percents with means, and it's going to be right here at the level of significance, where you're going to give it to you as a decimal for percent. So be careful with the means. That can be tricky. So we know P, and we know P, and then we got to figure out the number and then the thing. Do you get that this is P naught? Like, what's the clues that says this first sentence gives us the assumed value of the population?
Truth? It's usually the first sentence.
That has held true so far. The one question you're going to get on a final exam, it's going to be in the last sentence.
Dang it.
Okay, that's maybe a better one, what Will said. It doesn't say sample anywhere. And then later it does say sample.
That makes sense.
That's something that will always be true. So it doesn't say sample, and then it has this implied all right here. I don't know if it's going to happen that it will not be in the first sentence. Sometimes it isn't in the first sentence. So far it has been. Okay, so what is our claim? Can you find the key word that says, here comes the claim?
Believes.
Lower.
Good.
Lower this
Believes.
year. Believes.
That's the word. And then right, good. And then the actual word we need is lower. Ugh, I don't even want to talk about B. I'm so sick of verifying the requirements. But let's highlight C3. That's the one that you're most likely to get wrong because it's different than the ones you've been doing. Remember, use P naught and Q naught there. And then, of course, when we get to means, you're just going to see, is the sample size greater than 30? Remember that from chapter 9? So we'll sprinkle that back in. And then you just do steps 2 through 6. Go ahead.
I said, unfortunately.
Unfortunately, I know, right? Well, really, the thing is, we're like giving these each piece to you, right? And then we're going to do the review, the chapter 10 review, and that's going to be the most important one, because then it won't be all proportion stuff that we're doing. You have to figure it out.
Yeah.
But you got the keys. It's the same stuff as from chapter 9. Do you see percents or do you see means? Do you see the word average or rate? Do you see standard deviations or percents? I don't know. Okay, so I guess I'll leave the rest of this for you all to finish. I won't see you until Monday of next week. Feel free to ask questions about this. I know this is due on Sunday of next week, but remember, due dates are encouragements to keep you on task, not punishments. So if you don't make the due date, that's okay. I do believe I have all of everything up to date in the computer, other than the one you want me to do the most, which is the
Yes.
sample, the sample midterm.
Yes.
And like, I'm so happy to wait on that one, because all that's going to do is raise your grade, and no one gets upset when your grade is raised.
But I get upset when my grade is not raised,
You're
like reject
raise it
and
up.
not reject.
So here's what's going to happen when that goes in. If you got 100% on it, which I assume most everyone did, your midterm final grade will go up 4%, roughly, maybe exactly. So if you got an 89% in as your midterm grade, it will go up to a 93%. The lower you scored on the midterm, the more of a bump that becomes, because so it's not exactly that, but it's pretty close. So it's going to happen before the end of the semester. Everything else is in. That's all it. Okay, so what questions, concerns, comments do you have for me? Keep complaining about the grades not going in, and they're more likely to go in. That's a good kick to my pants, if you will. It was really helpful to talk to Cindy, because then she's like, Eric, go put those grades in on your trip. And it happened, right? She told me to do it and I did it. So maybe it's more effective to complain to her to then tell me to do it. Sorry, it shouldn't be that way, but whatever gets the ball rolling. So it's 8:02. I don't want to hold anyone, but I do want to answer any questions. I think we've done it. What you'll do with Cindy tomorrow is you will look at the 10.3, which is just everything means. Yes, have a great Thanksgiving, everyone. Enjoy it. Don't worry about doing work. Feel free to email me if you do. I'm still having office hours tomorrow, 8:30 to 11. If you want to try to meet at some time to discuss anything, homework, grades, whatever, just send me an email and we can set a time up. Even if it's Thanksgiving Day. I mean, I don't think that's going to happen, but I'll offer it so it makes me look good. So test me. There's safe bets out there, right?
Oh, gosh. All right, guys, have a great Thanksgiving.
Yeah.
You
Bye.
too. Bye-bye.